All right. Hello, geometry. What I'm about to take you guys through or explain is what's called constructions within geometry. And for those of you that might not get along with numbers per se so much, this is really something that I think you might grasp onto, and it's a hands-on activity. And so I really hope that you enjoy what we're about to do with the instruments that we're going to be working with. But I also want to encourage you, you have to be creative as you think through what we are doing, because at the end of the tutorial that I'm going to be walking you through, you are going to be expected to apply what we've just learned, okay? And so you're going to notice that with each construction that we're going to do, there are two different sections within each construction. And I'm going to do the first one for you, and then you can go back and repeat it for that second one to just kind of do it by yourself. And if you have to rewind the video, go ahead and do that. I really think that it'll hopefully will make it more solidified in your mind as to what we're doing. And so the supplies you're going to need, you can see on the paper there. You're going to need a pencil. Do not use a pen because you're going to make mistakes as you go through this, okay? I also want to encourage you that the markings that you're going to be making with the straight edge, with the compass, with your pencil, are what I will be grading, okay? So don't erase any curves or markings, dashes, whatever. I can sort through stuff that you may have put too much on, and that's fine, okay? But leave everything down there. It's just like showing your work in math. You know, don't just write an answer down. Show me what you did to get the answer. That's the part that's important for me. So next thing, internet. You got to have the internet on my calendar. You can check any date between the time we got off for Christmas to the time you return from for break. You can click on that site and then see the exact internet address. Okay, and obviously if you're listening to me right now, you've done that, so that's a good job. You need a straight edge, which you can find anywhere, all right, and a compass. Now you may have to go out and buy a compass. I think probably in class I've told you the better type of compasses to buy, and so hopefully you've gotten a decent one. If you don't have a good compass, it's going to be hard to make accurate constructions. Okay. Now, with that being said, I'm going to encourage you to use the whole packet and to move the paper more than your compass as you work it. You'll see what I mean as we go through these, because I always notice that when students first start doing constructions, I don't know what it is, they just can't move the compass quite like how it's supposed to move. And so hopefully you become a better user of the compass tool as we work through these. So the first construction that we have up here is we're going to construct congruent segments. And so the first thing I want you to do is to go ahead and take your straight edge, and we're just going to draw a ray with this straight edge. So anywhere on there, and I'm going to go ahead and just label one endpoint. I'm going to say it's going to be point E, and that ray is going to continue on forever. Now we're going to label a segment the same length as AB, and in order to do that, we're going to go ahead and take this compass right here, and we're going to place one point on one endpoint and one point on the other endpoint. Okay, now I will tell you this, it's kind of hard for me to be extremely accurate with this technology on this big board here, but hopefully you can be much more accurate on your paper there. But if you take that compass and you just place one endpoint on E, and then with your pencil mark, go ahead and make that mark. That distance right there, that distance is the same length as this distance over here. And so I'm going to make that point F, and as a result, what we've just constructed, therefore, I know that AB is congruent to the length of EF. Okay? So right about now, if that all made sense to you, you probably want to pause the video and do the same thing with CD. Now, your length of your next segment doesn't have to be tilted just like CD does. You can make it completely horizontal like we did the first one. Okay? Let's see here, right there. Okay? That doesn't matter. The tilt doesn't matter. What does matter is making sure you have the exact same length as CD. So go ahead and do that for me, and I'll be waiting for you here when you're ready to go for the next construction. All right, so hopefully that first construction was easy enough for you after you got a chance to practice the one on your own. Okay, so the next construction that we're going to do is we're going to construct congruent angles. And so what I'm going to do is I'm going to again start with the exact same thing that I had before, array. Now let's go ahead and label this point A. I'm going to label this point D. Okay, and we've got our array here. Now in order to construct, oh, I didn't mean to do that. There we go. Okay, in order to construct congruent angles, we're going to take our compass and place the point on the vertex of the angle that we're trying to copy or make congruent to. So I'm going to go ahead and draw an arc. Notice right here as I draw this arc, keeping that same length there. So don't change this length right here. Okay, this right here I'm going to label as point B, and this right here is going to be point C. Now, what do you notice about the length of AB and AC? Well, they're the exact same length, okay? So I'm going to come over here, and on this point D, make the exact same arc. Okay, make sure that you have that same arc right there. Now, I'm going to go ahead and label this point F, okay? And then from there, I'm going to go ahead and measure the length from B to C. Now I'm going to tell you why I'm going to do that in just a second. Okay, and I'm going to transfer that over here. Okay, now before I talked about leaving these marks up here, this is what I would be grading. This over here is what I'd be grading to make sure that you've done this correctly. And so I'm going to go up here to point D, and I'm going to run a line from point D through the intersection of those two arcs. Okay, and I know now, I'm going to label this as point E. Okay, I know now that this angle at D has to be the same angle that we have here at angle A. And how do I know that? Well, here's what I want you to understand. We know that the length here at DE is the length that we have here at AB. Okay? We also know that AC is the same length that we have at DF. And if you were to go ahead and connect B to C, and if you were to go ahead and connect D to E, that length right there is the exact same length. Okay? And so as a result, these triangles here, triangle ABC is congruent to triangle DEF by side, side, side. And we then know that angle A is congruent to angle D by CP, CTC. Okay? And so that's how you reproduce congruent angles. All right, so again, take a moment, pause your computer, and see if you can do the same thing. Now, you notice it's an obtuse angle. I wanted to change things up a little bit on you, but the process is exactly the same. So if you have to, rewind and check the construction over again. Okay. Well, I hope you were able to reproduce or reconstruct that obtuse angle. And so now we're moving on to producing a perpendicular bisector. Now, we've really hit this hard this year, and you guys are doing an excellent job of remembering perpendicular. What's it mean? Two lines intersect, form an angle. Good. Okay. Bisector, what's that mean? Well, it's cutting the segment that it's cutting in half into two equal segments. Okay. And so what I'm going to do, and you've actually seen me do this construction already before, once before, so I'm actually going to take my compass, place one tip on the one end point, and I'm going to go ahead and make an arc both above and below. Now, I have to stretch this length right here greater than half, and you'll see why in just a second here. So I'm going to make an arc below, and I'm going to make an arc above. Okay, and I'm going to come over here to the other end point, and I'm going to do the exact same thing. Make an arc above, and make an arc below. All right. Now, the reason we had to stretch this compass to greater than half the distance of this line right here is because if we didn't, then these arcs would never cross. Those two circles that we could form from that compass would never intersect. Now, the reason we need them to intersect is because I now know that this point right here, I'll label it point, let's label this one first actually. I'll label this point A, and this one point B, and this one point C, and this one point D. So what I know right now, forming these two intersecting arcs, is that this length here from A to C and this length here from B to C is the exact same distance, and this length from A to D and this length from B to D is also the exact same distance. And so if I connect those two points right there, with that line, I guess it was off just a smidge there, but that's going to be the perpendicular bisector of that segment right there. Okay, I'll label that intersecting point, point E. All right, so this is kind of reviewing of what we talked about just before we went on Thanksgiving break, which was this. If 2 points are equidistant from the endpoints of a segment, then the 2 points lie on the perpendicular bisector. Okay, all right, and so, yeah, pretty simple construction. Anytime you want to form a right angle, and you're going to see this a lot as we move forward, especially into the later problems that you have to reproduce for me. When you form a perpendicular line, it forms that right angle, okay? So, again, go ahead and pause and see if you can do the other construction. All right, the next construction that we're going to be working on is doing an angle bisector. Now again, angle bisector means we're cutting an angle in half. And so what I'm going to do is I'm going to first of all label that point right there. Let's label it point A. Okay. I'm then going to take my compass. I'm going to put the pointed part right on that angle. And then I'm going to make an arc right here. Okay. Now basically I've identified 2 points along this angle. They're the same distance from each other. So I'm going to make this point B and this up here point C. Now from there I'm going to take my pointed part of my compass and I'm going to stretch it to greater than half the length of the angle between C and B. So as you see right now, if I were to go ahead and start in here, this wouldn't work with what I want to do. It's got to be greater than half the length between B and C. So right there, that would definitely work. So I'm going to go ahead and make an arc with that length, and I'm going to come up here at point C and do the exact same thing. All right. Now, I'm then going to connect the vertex of my angle to those intersecting arcs. And that right there is the bisector of angle A, okay? Now you may be sitting there thinking, okay, why does that work, okay? Well, what I'm going to do to prove to you that this will be an angle bisector, besides the fact that it looks pretty accurate right there, it looks like two congruent angles, I'm going to go ahead and connect point B to the intersecting arcs. Oh, that didn't work out so well. Try that again. Okay, point B to the intersecting arcs, and then point C up here to the intersecting arcs. Okay? and I'm going to label that point D. Okay? And so what we have here, we already said that AC was congruent to AB. Okay? We made that arc right there, the same distance from point A. Good. Now, what we did here, from this point, we made an arc, and this point here, we made an arc, and this point right here is the same distance from both sides of the angle. So I'm going to go ahead and make 2 congruency marks there. And if you look at the triangle ACD and triangle ABD, you'll notice that the triangles are congruent by side, side, side. And so actually I'm going to write that down. Triangle ACD is congruent to triangle ABD by side, side, side. Okay? As a result, these two angles here inside have to be the same measure because they're in corresponding positions to each other. All right? And so that's why that construction works right there. And so go ahead, use that obtuse angle now, and see if you can go ahead and reproduce the angle bisector. All right, I can't tell you how much I enjoy giving this to you on a video feed as opposed to me presenting it in class, because now you can go back and look over things. When I have to restate things, it just takes too much time. So really glad that you guys are able to do this looking at the video. The next one that we're going to look at is constructing a line parallel to a given line through a given point. Now, anytime you think of parallel lines, I hope that we have hit home that chapter 3 concept of there's 3 characteristics that have to hold true. 1, the alternate two angles have to be congruent. 2, the corresponding angles have to be congruent. And 3, the same side and two angles have to be supplementary if the lines are going to be parallel. And so you're actually going to see one of those 3 concepts play out here as we go ahead and reproduce a line parallel to this one down here that's going to pass through that point right there. First thing I want you to do is go ahead and take your straight edge and go ahead and draw me a transversal. If you remember what a transversal is, it's a coplanar line with 2 other lines that intersect them. Okay, so it's the line that is shared between the 2 other lines that we have a relationship with. Now what I'm going to do is I am going to take my compass and place, let's label that point A. Okay, place it on the vertex of the angle that's been formed, and I'm going to go ahead and make an arc that goes through both sides there. Now I'm going to label this point B. So now I've got line AB. Okay. And you can make this point C up here. Ooh. Point C right there, okay, which is fine. And what we're going to do is we're going to reproduce this angle down here at A up here at this point right here. In order to do that, we're kind of going to do it in an opposite fashion. We're going to start up here at the top and work our way down. Okay, so let's say that this is point D, and I'm going to make this point E. Now, if you remember, when reproducing congruent angles, not only do you need to have this arc right here, the same distance from that point as this arc is from this point, but you also need to have this length here be the same. So I'm going to go ahead and make sure that that is the same length right there. Okay, again, that's an arc, that's a part that I would actually be grading if I was grading your construction. And I will be collecting this homework when you get back to school. So, and I'm going to come over here and make that same arc. Bam. Yes. All right. Now, as I finish this up, I'm going to go up to this point D and connect that to these intersecting arcs. And hopefully, what do you think? Look pretty parallel? Looks pretty parallel to me. What did we do? Why does this construction work? Well, the reason this construction works is because you notice that this angle and this angle are congruent. What type of angles are they? Well, they're corresponding angles. And so we have learned in the past that if corresponding angles are congruent, then lines are parallel. Okay? Now, some of you may be thinking there to yourself, as in, could I also do alternate interior angles? And the answer is definitely yes. If you were to go ahead and reproduce this angle here over here, then yes, you could do alternate interior angles as well. And so that would definitely work. If you wanted to copy this angle here and move it over here, again, that would be alternate interior angles. And so, again, that proves that these two angles are supplementary, as are these two angles. So again, the same side interior angles are supplementary. So take a moment, see if you can go ahead and construct a line parallel to this one over here that passes through that point. All right, now this next one is actually one of the ones that's going to kind of lead you into the ones that you're going to be doing for homework over after you get done with this video. And so there's more than just one construction involved. And so here's what it says. We're going to be constructing special quadrilaterals, so a specific type of quadrilateral. Has segment lengths A and B, and what we're told is that this quadrilateral ABYZ is going to have a side that's going to be a length of A, this length over here, and another side the length of B, this length right here, and that the two sides that we produce, A and B, have to be parallel to each other. And so there's actually lots of different ways you could do this one. There's no one set way that you could construct it, and so what I'm about to show you is just one of the ways. So again, as I said before at the very beginning, you're allowed to be creative with this, okay? As long as your creativity adheres to the rules that we've taught within construction. So feel free to be creative as you make up your construction here. All right, so here's what I'm going to do. I am going to go ahead and draw a ray, just like I started with before, and I'm just going to make a point on that ray. Doesn't matter where it is, and I'm going to label that point A. Okay, this is going to be the A of the quadrilateral ABYZ. Okay. Now from there, one of the side lengths, AZ, has to be a length of A. And so I'm going to go ahead and make this length right here, right there. Okay. So this is going back to the very first construction that we had tonight, transferring that same length all the way down here to our picture. Okay. Now you want to make sure that you make a mark big enough that I can see that, yeah, they transferred it over, and you can go ahead and label that point Z. And if you want to just validate it to yourself that you knew what was going on within this construction, you can go and say, yep, that length is the length of A. Okay. Now what we want to do is make this line segment here parallel to the one that we just constructed down here. So what I'm going to do is, again, I'm going to draw a transversal. It doesn't matter how that transversal is drawn. If you want to make it completely, try to make it perpendicular to the one that's already there. If you want to make the angle a little smaller so it's more acute, that's completely fine too. And so I'm going to go ahead and draw that in. Okay. And then I'm going to place a point along this line. It doesn't matter where it goes. Okay. All we're told is that one side length needs to be A, the other has to be B, and they have to be parallel. So I'm going to make a point on this line right there and label that point B. Okay. Now, as we did in the last problem, because lines have to be parallel, I'm going to make the corresponding angles congruent. I'm going to duplicate this angle right here up here. Okay. So as I move my straight edge out of the way, I'll shrink this down, take this over here, move that. Okay. So if you remember from the previous presentation, go ahead and make that arc there and transfer it up there. Okay. The next part, this is the part I want anyone to forget. We need the width of the angle, I guess you could call it, the distance from one side of the angle to the other side. So if I show that mark there, oh, that is that length. And you bring it up, and you do it over here. All right. If I connect point B to the intersecting arcs, that right there should produce a line that's parallel to a Z. Okay. Now I can actually Go out here a little further. Draw on that line. Okay? And then from there, we want this line right here to be parallel. We want this one here to be parallel to this one down here. Or I'm sorry, not parallel, but we want this one to be a length of B. So what I'm going to do is I'm going to go up here, use my compass, stretch it the length of B. Whoa! Big splits. Right there. Okay. Go down here, transfer that length, show that mark so I can, one that needs to be graded. And if you want to, you can go ahead and say, yep, this is the length of B. And then I'm going to connect the endpoints of both segments. This one right here with that one right there. Okay? And you may be thinking to yourself, man, that's a messy picture. All right? But to me, that's good work right there. I love seeing these arcs. Okay? I love to see that because I know what you've done. If this part extends out, I don't care about that. Okay? Don't erase that. That's beautiful stuff right there. All right? So that would be the figure. Now, here's a question for you. We just got done with the chapter on quadrilaterals. Can anyone tell me what type of quadrilateral this would be? Hint. You've got exactly one pair of parallel sides. All right, very good, very good. It is a trapezoid. Now I should probably do this. It does say quadrilateral ABYZ, so I'm going to put the Y right there, and then I'm going to go ahead and say trapezoid ABYZ. All right, good job. Now you notice there's no other one to do on this one because you're going to be doing some of this stuff for your homework practice on your own. So I didn't want to put you through another one of those tougher problems. So, all right, here we go. Let's go to the next one. What do we got next here? Perpendicular at a point on a line. Okay, we're revisiting perpendicular lines. We're going to really get you guys to understand perpendicular lines form right angles here. All right, so what I'm going to do here is I'm going to start out by taking my compass, again, putting the point part right there on the dot, and I'm going to make an arc on one side of the dot, and I'm going to make an arc on the other side of the dot. Now, the reason why I've done that, and actually we can go ahead and label these points. Let's label this point A over there. Let's label this one point B, and let's label this one point C. The reason why I have to do that is because I know that AC is the same length as AB, okay, and that'll be key for what we're going to do in a little bit here. Now from there, I'm going to go ahead and take my compass, and I'm going to, again, stretch it more than half. So right now, if you notice here, that's exactly half right there. So I'm going to stretch it more than half, and I'm going to go up above and make an arc. And I'm going to do the same thing from the other side. Make an arc. Okay? And so this point right here, point D, is also the same distance from point A as it is from point B. And so these 2 points, B and D, are the same distance from these two endpoints, A and B. Now, as a result, I'm going to reiterate some things that we talked about just a little bit ago, and that's this. If you have a point that is the same distance from the endpoints of a segment, so granted, this isn't a segment, it's a line. Notice the arrows here, okay? But we've made it into a part of a line, which is a segment. So this point right here and this point right here, D and C are both the same distance from. So as a result, they both lie on the perpendicular bisector of that segment, okay? And so what you could say is this. Now, granted, it is a line, so I probably shouldn't have put in those congruency marks there. You can actually ignore those. That wasn't the goal of the presentation here. So you can go ahead and say that DC is perpendicular to, excuse me, AB. Okay? All right, so go ahead and try the next one for me, and then we'll do our last construction. Almost done, folks. All right, now, I just realized something, and I've already printed off all of your papers here. And if your paper is not printed off correctly, I apologize. Construction number 8, I think, may have bumped up to the previous page. And so if that happened, please go ahead and redraw it down here. Construction number 8, perpendicular from a point on the line. And I think that this line may have disappeared. So if you could go ahead and redraw this line for me with a point out there, I can go ahead and grade it from there. And so you'll notice here there's a lot of similarities with what we previously did on the construction of perpendicular lines with what I'm about to do. And so I'm going to go ahead and I'm going to draw an arc that intersects this line at 2 distinct points. So I'm going to make an arc here and an arc here. And so if I were to label this point right here, let's label it point B, and let's label this point right here point C, and this one point D. We know that the length from B to C and the length from B to D are both the exact same length, okay? And then what I'm going to do is I'm going to come down here, and I'll just warn you, if your compass right now is not greater than half the length between C and D, then you need to stretch it to be even further. It has to be greater than half in order for this to take place. And so I'm going to go ahead and make an arc with that same length right there, and make another arc with that same length right there. And that point, I'll just call it A, is the same distance from A to C as it is from A to D. Now, if I go ahead and connect A to B now, the result is going to be a perpendicular line. Okay. Now, why does that take place? Well, this actually ties in nicely also with something that we just talked about, and that's this. If you go ahead and connect A to D and connect A to C, and connect, let's do D to C, that way I don't have to move the straight edge again, and connect, maybe I will have to move again, and connect D to B. All right. The question I would pose to you is this: what type of figure is quadrilateral ACBD? And the answer, if you saw, I never adjusted my compass in any way, and so therefore this length here, and this length here, and this length here, and this length here are all the same, and so it's actually a rhombus. Rhombus, and I'll call it ACBD. And what do we know about the diagonals of a rhombus? Well, they're going to be perpendicular. So as a result, AB is perpendicular to CD. And actually it's a line. Okay? I should probably put the line up there too. Okay? All right, so again, go ahead and do the construction that we have off to the right there. At least I hope it's there. If it's not, go ahead and put it in there. And then I'm going to give you a couple of hints as to what you need to do for the next couple of problems, numbers 1 through 6 for your homework. Okay. Now, I'm going to step away, and I'm going to let you guys become creative. You got to think back to what we've done so far to try and do the new steps that you're going to need for the constructions I'm going to ask you to do. And so they actually end up being pretty cool if you can work through them. The first construction, I'm just going to give you some hints on some of these. The circumcenter, think back, chapter, what is that, 5? Circumcenter. How do we form the circumcenter? Well, I know the circumcenter is used to circumscribe a circle about the triangle. And what was it? Perpendicular bisectors. You're going to have to perpendicularly bisectors. That's where the perpendicular bisectors meet. So you're going to have to actually determine where the perpendicular bisector is on this segment right here, this one right here, and on this segment right here, okay? And then the third one right there. Now, do you actually have to do all three? No, you shouldn't, because remember, they are concurrent at a point, and that point is going to be the same distance from all three of the vertices of that triangle. All right, so again, that's a cool construction right there. You can work on that. You might even be able to find a construction online that someone could help you out if you really get stuck, but try to do that one on your own, okay? The next one is the in-center, all right? And the in-center, if you remember, is used to inscribe a circle inside the figure. So somewhere inside there should be a circle, and it's going to touch all the sides of the triangle, okay? Now the in-center comes about, if you remember, because of some angle bisectors. The bisectors of all three of the angles, okay? The bisectors of all three of the angles will meet at a point that's concurrent called the in-center. And then from there you can do that, the inscribing of that circle within the triangle. So that's again, a pretty cool construction. All right, now for the rest of these, let's go on down here. You're going to use these three segments, A, B, and C, to start doing the following type of constructions. So I'll be honest, numbers 3 and 4 are very similar, I think if I remember right. Number 3, you've got a rectangle right here, okay? And so what you're going to have to do is you're going to have to form some right angles. How do we form right angles? Remember, we developed some perpendicular lines. And so use that as a hint for that one. A square, well, what's that got? Well, it's got perpendicular lines which form those right angles. So keep that in mind. A rectangle, well, we've got a rectangle which has right angles. Again, it's going to be used perpendicular lines. All right. And then the last one is a right triangle. What the right triangle has? It has a right angle, which comes about because of perpendicular lines. So again, I honestly hope that you guys enjoy doing these constructions. I know it stretches you a little bit. It forces you to use your hands and draw and might force you to be creative in a little bit different way, but I really enjoy this. And so if you've struggled at all in geometry, hopefully you're able to pick up on this type of mathematics. So I appreciate your time. I appreciate you listening to me, and I look forward to seeing everybody when we get back from break. So peace out.